consciousness and spirituality from the neuroscientific perspective. Uh, we would the first agenda on the program today is to do an inauguration. I request Dr. CUV to light the lamp and inaugurate the program. I'll just do a brief introduction of this colloquium. The idea is to make a brief presentation of the two listed topics, evoke an academic discussion from the learned audience, collate and summarize the discussion, which will be primarily the work of Professor Natarajan, explore viable options to unresolved issues, if any, and discuss on any other matters arising. So the first topic is a brief discussion on self and consciousness by Dr. Thiagarajan, and he's going to take 15-20 minutes to highlight this issue, and then there'll be a discussion at the end of the second talk. So the second topic is by Dr. Vasudevan, who will be talking on the neurology of spirituality, and as you know, fear was the first reason why God arose in our brains, and then it evolved, and we don't know why the evolution stuck to this God thing in the whole process. So the future colloquia are designed based on what feedback you give us. So I've basically chosen a few topics like meditation, near-death experience, quantum consciousness, out-of-body experience, remote viewing, and any other suggestions that you might ask us to consider for the next oncoming symposia. So I would stop with that, and it's my pleasant duty to invite Dr. Thiagarajan to speak on this topic. And before I hand over the stage to him, I'd request you all to log on to this site and post your comments and commentaries and your thoughts that may arise after you have left the meeting, which happens most often. And once you give your email IDs, we will log you on to this. Thank you very much. Sit back and enjoy the meeting. Thank you. Dr. Thiagarajan.
Thank you. So I'm here to talk about consciousness and the self. The most interesting part of this colloquia is the discussions. I'm really hoping for a very robust discussion after this, because this really isn't a topic where any of us knows any more than anybody in the audience. It's just the talk is just a stimulant that opens up the floor, and I'm hoping that we'll have a really robust discussion at the end of it. In all humility, I know very little about the neurology of consciousness. Daniel Dennett, a philosopher, I disagree with a lot of what he says and thinks, but there's one thing he says a mystery is something that we don't know how to think about. A mystery is something that we don't know how to think about. And all that I'm doing today is my suggestion for how to think about the neurophysiology of consciousness. I think there's a fundamental mistake that's being made in the approach to consciousness, in explaining the brain basis of consciousness, which is not to say, finally, that consciousness is only brain-based. But if we're going to try to explain it in terms of the brain, then I think the approaches we're taking is wrong. And in the discussion, I think there will be people who will talk about the fact that it cannot be described as something that is merely brain-based. But that's another topic, and I hope. So first thing for definitions, I want to define the word sentience. So sentience is a capability of sense perception, capability for feeling. So any being, I don't have place for this, that is capable of a first-person, subjective, qualitative experience. Like, if I pinch my skin, the peculiar a quality of distress or pain that I experience, it's not just sensation, right? Pain is a sensation, but suffering is a psychological experience. So the complex psychological first-person qualitative experience of suffering that I experience when I pinch myself, that is sentience. And consciousness is merely that you add the element of self-awareness, that it is awareness of experience. You're aware of the self, and then you say, I am experiencing this experience. So consciousness I define as awareness of experience. And finally, we need to define the word qualia, because that's going to figure quite importantly in the discussion. The qualia is a unit of subjective experience. So I mean, the single for it is quail. Qualia is any, same thing. It's a unit of subjective or first-person experience that we have. Okay, so that's part of the definition part of it. So you all know the history of how consciousness has been looked at least in terms of Western philosophy. You had Descartes, the philosopher in the 16th century, who said that consciousness, the higher mental functions such as consciousness and spiritual experience cannot be defined in terms of the brain. Only so-called lower nervous functions can be. The brain, there's a fundamental dualism between the body and the mind cannot be spoken of in terms of the functions of the body, including the brain. And lots of philosophers, even today, as my brother was saying, most of us, we are dualists in the sense that at some level we think of the existence of a soul, and we think of consciousness and conscious experience as based on the soul, which we don't think has a basis in the brain. So many of us are dualists, although we don't define that position very clearly. We think of ourselves as dualists, or we would be called dualists. Gilbert Ryle, who was a philosopher, an English philosopher in the 20th century, he actually was he was countering Descartes. He was making fun of Descartes when he coined the term "ghost in the machine." But his objection to the Descartes mind-body dualism was philosophical. He says, you cannot compare mental experience and the physical universe. Philosophically, they're two different categories. It's like saying that an orange, a physical orange, and the experience of an orange is the same thing. It cannot be the same thing. See, one is a subjective mental experience. The other is a physical reality. So his point was the idealist theory of the mind makes a basic category mistake in reducing physical reality to the same status as mental reality. And similarly, the materialists, they make a basic category mistake in reducing mental reality to the physical universe. So that was his objection. And then, of course, you have the famous John Eccles. Neurologists are much more familiar with Eccles, the man behind synaptic transmission in the old muscle spindle and the reflex arc via the spinal cord to the quadriceps. He actually thought synaptic transmission was electrical, but it was his work that led to the discovery that synaptic transmission is chemical. So he received the Nobel Prize, as you know. He was an Australian neurophysiologist. But he was an out-and-out dualist, and he said there are three worlds: World 1, World 2, and World 3. World 1 is the world, the physical universe, with its atoms and its quarks. The physical universe is World 1. World 2 is the mental universe, the experience, the subjective experience, which is soulful and cannot be explained in terms of the physical universe. And World 3 was the world of ideas, all of the human or achievements in art, science, the body of knowledge. He, like Plato, he believed in the independent existence of a world of ideas existing independently of the physical universe. So he called, and there's a beautiful statement of belief where he says, at the core of World 2, which is the subjective universe, at the core of World 2 is the self, which is the basis of our unity as an experiencing being throughout our lifetime. So I want you to remember that, because there's somebody who will be coming along next who counters that. At the core of World 2 is the self, which is the basis of our unity as an experiencing being throughout our lifetime. So that was his statement. As against the dualists, you have the monists who say, absolutely not. Consciousness in all its complexity including all of our spiritual experience, can be defined in terms of the functioning of the brain. And I think a lot of these people who talk about the brain, there is a fundamental problem, because the mind is a different concept from the brain. The mind is a larger concept from the brain, and I will come to that at the end of my lecture. You cannot equate the mind and the brain, but that's a separate argument. Anyway, the monists believe that the consciousness could be explained in terms of the working of the brain. I'm going to talk about the first of the monists, Daniel Dennett, and his computational theory. So in the 1980s and 1990s, with the discovery of the computers, artificial intelligence became very popular. And this whole idea of explaining the workings of the brain as a complex computer took on a lot of interest. And Dennett, along with, you've heard of Marvin Minsky in Boston, who worked on artificial intelligence at MIT. So Dennett is of that club, and he has this computational theory. So basically, he talks about serial circuits, computer circuits, serial processing, which is the von Neumann computer, which is most of our computers, they process serially. He talks about parallel processing, which is something that the brain does. Parallel processing is a little more complex, because not only are there parallel circuits, but at the level of each of the nodes in each circuit, all of the nodes in one level communicate with each node in the next level. So you have a tremendous amount of input into each node at every level. All of the nodes of the previous level communicate, and the output is a summation of all the input that comes in. So it's a very complex model. Parallel processing is a complex model, but that's how the brain works. And so he talked about consciousness. The first thing he said was, there is no central place in the brain where there is a self, where there is a sort of overlord who directs the whole drama and who directs everything, including dreams and including consciousness and including all the functions of the body and the mind. There is no central place like that in the brain. He says, the consciousness and all of mental activity is just a series of mental states, a series of mental states that occur. And some of these mental states rise to the level of consciousness, but it is just a constantly changing scenario of mental states changing. There is no central. Very, very clearly arguing against the position that in the previous slide we saw that Eccles took. But he says, so his definition of consciousness, he says, is a virtual von Neumann serial computer program superimposed on the parallel circuitry of the brain. That was his theory. It's a purely, very hard artificial intelligence computational theory of the brain, of the mind, of consciousness. There are two people who argued against that in very scientific terms. One was a chap called John Searle, who has this Chinese box experiment. The Chinese box, the Chinese room experiment is very simple. Now, just suppose you're in this room, and there are two doors to the room. One door, something comes in, and it's Chinese symbols, all Chinese symbols. Now, you don't know any Chinese. You have a set of instructions that say, match these shapes to these shapes. They're all Chinese letters. We don't know Chinese, so we receive the input on that door. We arrange the information that comes in according to the book that we have, and then we put it out the next door. He says that is what a computer does. What a computer does is it manipulates symbols. The 0 and the 1, that is part of the binary basis of computer functioning. The computer manipulates symbols. That's what it does. And he says, so what we do is syntactical. That is, there is an organizational structure that a set of instructions that we follow in organizing information and pushing it on to the next level. But that is not the same as semantics. So he uses syntax is not the same as semantics. And what he means is when we process. When we use words to describe something, they have meaning for us. They have a semantic quantum. So when I say apple, it is a semantic phenomenon, not a syntactical phenomenon. It's not just a series of symbols put together. So he said, we can never be computers because the computer is manipulating symbols. It does not understand what it is manipulating in the same way that we who do not know Chinese are putting things together. So, if all of us were rearranging Chinese symbols and pushing it along, we're doing the right thing, but we have no idea what is being said. The Chinese we don't understand. Similarly, the computer does not understand. There is no semantics here, it's only syntax. Therefore, we can never be a computer. That was his argument, John Searle. Roger Penrose, he's very famous, as you know. Penrose, he used two very, very famous discoveries, ideological discoveries in the 20th century. One is a mathematical thing called Gödel's theorem, and the other was, of course, quantum mechanics. So Gödel's theorem basically states that, let me just, I need the help of this sentence. Gödel's theorem basically says there are true statements in mathematical systems which are not provable as theorems of the system. There are true statements about mathematical systems which cannot be proved as theorems within the system. I'll explain. I'll use a very simple example. It's too complex for me to understand. I could be very, very humble. I didn't understand Gödel's theorem when I was reading Penrose, but I understood an example that John Searle took in trying to discuss Gödel's theorem. So he says, there is a problem called the unsolvability of the halting problem. The unsolvability of the halting problem goes like this, yeah? Now, if you gave a computer an instruction, you said start with the numerals 1, 2, 3, like that, and say stop at any number above 8, it would stop at 9. The minute it touches 9, the program would end. But if you said start at 1, 2, and 3, and stop at any even number, which is a sum of two odd numbers, it wouldn't stop. It would just go on, because there isn't an odd number that is a sum of two even numbers. It would just go on. Now, the computer does not understand that it is unstoppable. We know. Now, he takes very complex example. The actual Gödel's theorem is you take all of the set of the mathematical problems, okay, and you say, you give it the word A, and you put an, which is n for any value of a numerical, and all the mathematical processes are A. He says, if you have a process, say, for example, the summation of all the processes kn, which will tell you which is stoppable and which is not stoppable, there are certain values of n for which the k, the sum of processes, cannot actually tell you that whether this is stoppable or not. So he says, basically, any system that computes, any system that purely computes, cannot know something that we as human beings know, that a process is unstoppable. Therefore, we cannot be computers. That is his argument. Nothing that computes can go outside of the system and know the truth of a statement that can't be proved within the system. We can, and therefore we cannot just be computers. That is the argument of Roger Penrose. It's a complex argument. I don't pretend to understand it, but there it is. And he says, since neurons can be seen as computing in the sense that just as you have the 0 and the 1 as symbols in the binary system, as the basis of functioning of computers, you can speak of neurons as either depolarizing or not depolarizing. The summation of input to the soma of a neuron, ultimately it either generates a depolarization down the axon or it doesn't. So since the neuron can be seen as something that does compute, he says the neuron is not the basis of consciousness. He says at the subcellular level, the microtubules inside the neuron, their activity, if you explain their activity not on the basis of classical physics, but on the basis of quantum mechanical theory, and especially the indeterminacy, the principle of indeterminacy, which is central to the quantum mechanics, then you can explain consciousness. So it's very difficult to understand. But he said, we are not computers. The human brain cannot be explained in terms, or consciousness cannot be explained in terms of computing. These are some other monists, people who try to explain consciousness in terms, or struggle to explain consciousness in terms of the brain. Francis Crick. Crick is the famous Crick, Watson, Crick, and Wilkins, the double helix theory, the double helix of the DNA, Cambridge, England. So he has written a book, and he talks about synchronized firing as a possible explanation for consciousness. So he uses visual perception as his example. And in visual perception, of course, you have the perceptual categories. Initially, when the visual information is processed, it's color is processed, shape is processed, light and dark is processed, surface texture is processed. And then in the association areas of the brain, you have all of this information collated together, and you have a unitary experience. So when we see an object, we have a unitary experience of, say, an apple. But the information is actually broken up and then collated together. And this, he says, this coming together of all of the information in the association areas, this is the basis of consciousness, because there is an input from different parts of the brain, and they all fire synchronously. And he even names, he says 40 hertz, things like that. So synchronized firing of neurons, different sets of neurons in different parts of the brain, provide this unitary experience, and that is the basis of consciousness. That was Crick's attempt to explain consciousness. A chap called Gerald Edelman, very similar. He uses very, very similar theory. He uses the concept of maps, of neural maps. He says that we have different sets of maps for different perceptual categories of a particular object, like an apple or a chair. You process it using different maps, and the maps actually correspond topographically to the shape of the object. And then, between the different maps that represent that particular object, you have communication through parallel processing. And this parallel processing is so complicated that what it can do is it is capable both of memory, the process itself of communication between these maps is capable of both of memory and of value-based learning. Because he says, because any new input can change the way in which the maps communicate and can change the maps themselves, that is the basis of memory. We don't store memory in a particular part of the brain. We store them in this complex circuit of maps that represent the different perceptual categories of an object. And the way you change the communication, the way you change the maps, is the way in which you, and he said, this is the basis of consciousness. Consciousness arises from this. This is his proposition. Lastly, Israel Rosenfield, as he focused very much on the self. He says the self, awareness of the self, is the absolute basis of consciousness. Self-consciousness means first awareness of self and awareness of experience. So, and he said the body image, you all know that because of kinesthetic information, we have an image. I can close my eyes, I know exactly what the position I'm standing in is. I have a picture of myself standing. I have the picture of, what shape my hands are in. I have an idea of how my neck is inclined. I don't need to see it visually in a mirror to know. I have a map of myself right now as I'm. So each one of us right now, the minute that you become aware of yourselves, you become aware of your self-image, a map of how you're positioned. So he said the self-image is very, very important, and it's dynamic. He said it's constantly changing because of new sensory input. And this interface between new sensory input and the image that is there, this is the crux. This is the important point where consciousness arises. That was Israel Rosenfield's theory of consciousness. I'm just doing the history. Now, I've gone over the history. Now I'm just going to propose Tyagarajan's way of looking at consciousness. See, when reading all the things that these people say, you get the word subjective, qualitative, first person, value, meaning, significance, pain, and all of these are words for emotional valence. The amount of emotionality, emotional content in that particular experience. And yet none of them talks about emotion. None of them talks about the neurophysiology or the neurobiology of emotion. They use fundamentally cognitive approaches. So they present the problem of qualia like this. They say, now, a wine tasting, you know that wine tasting is a very complex, you have these special people. For that example, you have tea and coffee tasters also. They will go and they will take the tea or the coffee or the wine and they'll go and they spit it out, and they're able to analyze. They will come out with about 50 different flavors for what they've just tasted. Their palates are so exquisite that they can taste all kinds of things, and they will give a description of the wine or the particular tea, and they'll speak of all kinds of flavors. So he says, now let's suppose you develop a computer that is able to analyze all the chemicals inside of the wine, and can analyze the content of a particular wine in terms of all the maybe 577 chemicals, and can determine much better than any wine taster can what the chemical composition, what the particular flavor of this particular wine or tea or coffee is. So you would be able to construct a computer very easily like that, but the computer does not actually have the experience of tasting. It merely processes information. It doesn't taste. The wine taster tastes. So how is that? How is it that we have machines that process much more complexly, perhaps, than we do, but it doesn't have that first-person subjective experience, actual experience? And my point is that if you do not start with talking about emotional valence, if you do not start dealing philosophically with the problem of emotion and volition, you will never be able to explain qualia. You will never be able to explain sentience. You will never be able to explain first-person subjective experience. You'll never be able to explain consciousness. That's my point. A purely cognitive approach will not work, and I'll try to show you why. So this is what only a theory of consciousness that approaches from the point of view of emotion and volition will solve the problem of qualia. Now, this is the old, any psychologist, Dr. Savera is right here, so, this is how we, in Western approach to the mind, we talk about cognition, emotion, and volition. We know what cognition is. It's all of the information processing systems of the brain, of the mind. We put them under the cap of cognition, yes? So starting with, attention and perception, and then memory, and then thought, language, all of the information processing systems of the mind will come in. Volition, the will, is philosophically, it's a very, very complex and difficult concept to understand, but we at least know the effector apparatus. We know, for example, that you have the motor cortex, you have a center for praxis, which makes the ideas for movement, and then you have communication in the motor cortex, and then you, of course, have the corticospinal tracts and the muscles and the joints. So the effector apparatus of volition we know. So let's just think of a system where information comes in, is processed, and then the message goes out to the effector apparatus, and you react to the environment. Information comes in from the environment, you react to the environment. What is the necessity for emotion? Why emotion? You have cognition, and in response to cognition, you have volition. It's just this. What is emotion? Anybody? It's just this messy thing, feelings. When it rises to the level of consciousness, when emotions rise to the level of consciousness, we call it feelings. But actually, the phenomenon of emotion is largely unconscious. I'll prove it to you. But why? What is emotion? See, let me go to the next slide just before I come back to the slide. Let's talk about the id, the ego, and the superego, something that everybody knows everything about. I'm not here to tell you about the id or the ego or the superego. I'm just to remind you that. So the id is the summation of all the instinctual impulses of the self and the mind, yes? So all of the things that maintain physiological homeostasis. For example, if my blood glucose is falling, I feel hungry, I eat food. If the pH of the blood or the electrolyte concentration is changing, then my thirst mechanisms pick up, I drink water. So, hunger, thirst, seeking warmth, seeking security, the fight or flight reaction, that is either fear or rage, and also that which propagates the species, which is sexual feeling. So that which maintains or preserves the self and that which propagates the species. All of that can be summed up inside of the id. Id, as Freud, this thing is both a beautiful and a terrible concept, because the id is its pure need, its pure desire. It is sleepless. It has no idea of time, and it is the infant part of us, or the animal part of us, and all this thing is, I want, I want, I want, I want, I want, okay? But it's also beautiful in the sense that before life came along, when there was only non-life, there was no point of view. There was not something that desired to keep itself separate from the rest of the universe, that desired to maintain that separateness, and that desired to propagate itself. So it is a fundamental fact of life. It's a fundamental fact of the definition of life, to separate oneself from the environment, to maintain a separate identity, to preserve that identity, either through maintaining the self in a lifetime or propagating the self through sex. The ego is conceived of as merely one layer of the id, the front layer of the id. It basically manipulates the physical environment to provide for the needs of the id. That's all it does. So all of the sensory apparatus, all of perception, all of cognition is subsumed under the concept of ego. It just exploits the physical environment to better take the needs, to better serve the needs of the id. Right? What is the superego? Or for purposes of simplicity, we'll say conscience. Why a conscience? Again, messy. As somebody said, everything good in life is either immoral, illegal, or fattening. It tells us not to do the things we like to do. So consciousness is a very conscience is a very inconvenient thing. So why do we have the superego? In developmental terms, I mean, in terms of evolutionary perspective, why have we developed a superego? This is a discussion, friends. This is a discussion. Must be more robust. Yes? Fantastic. Yes, indeed. So basically, the superego is a part of the self, also a part of the id, which helps us negotiate the social environment. So, for example, I have Dr. Yogaraj is sitting next to me. There is an apple between us. Okay. Now I'm hungry. I want all of the apple for myself. My id says, "Go, eat it, take it." My ego says, yeah, you're closer to the apple than poor Dr. Yogaraj. You can probably grab it before he does. So you take it and eat it, So the ego calculates distance. I use my vision. I use all my reflexes. I say, I can get the apple before Dr. Yogaraj. So, and my id says, give me, give me, give me, give me. But my superego says, don't. Cut the apple in half. Give Dr. Yogaraj half, and you take half. Because tomorrow when he has an apple, he will share half with you. And when you have nothing, you will still have some apple to eat. Meaning that we are pack animals. Human beings are pack animals. We've gotten together to be able to survive better, because once we get together, then we have more power to procure food. We have more power to defend ourselves against predators. So we're able to cater to the needs of the id better when we group together. But then we need a superego to be able to take care of each other. Because I control my aggression, because my conscience tells me to control my aggression, I am safe from the aggression of others. Because my conscience tells me to share, then I have more access to food that I don't produce, because others are going to share with me. So it's really a fantastic, developmentally, it's a fantastic strategy. The superego is a fantastic strategy to better serve the needs of the id. Now, I'm not saying that that is what it is now. You know, we can choose to, we do choose to use the superego for spiritual and for ethical and moral